The learning objective of this section is how to use radar in a safe and efficient way for navigation, including how to make landfall, how to position own ship with reference to radar information, how to identify raycons, and how to use parallel index lines. The radar picture is a plain picture of the ship's surroundings as seen from the scanner. The 5 words, as seen from the scanner, are very important. Always remember that the radar cannot see what you couldn't see if you were up at the antenna. Some observations should be made for the fact that the radar horizon is 8 to 10% beyond the optical horizon, and that the radar can see both in darkness and in fog. Only long training and experience can teach you to interpret the radar picture quickly and correctly, and to identify different targets. Use of radar to assist in navigation can be divided into 3 categories: making landfall, coastal navigation, pilotage. Radar can be very useful, especially during bad visibility. However, and this should be remembered, initial radar fixes are often not reliable at long ranges, and when approaching land, the picture may change completely. The position of the reflecting surfaces of the individual targets are changed with respect to the antenna position whenever the range is altered, and pulses are more favourable or less favourable reflected. Sometimes this is observed as an apparent movement of land towards the observer, as the lower parts appear above the radar horizon. Better use of the radar as a navigational aid can be made near the coast. As reflecting conditions become more favourable, more accurate information becomes available. When taking a position fix by radar, one should remember that range accuracy is generally higher than the bearing accuracy. Radar position fixes, based on 3 radar ranges, are normally very accurate. In some cases, bearings must be used. Choose isolated targets of relatively small size and reduce the gain as much as possible, so that a fine echo is obtained and a beam width distortion is reduced. For navigation in narrow waters, radar is a great device, especially during reduced visibility. Usually, the ship position is not plotted on the chart. A short range must be used, occasionally switching to longer range for better overview. The existence of radar shadows caused by structures on own ship must be kept in mind at all times. In narrow channels, rivers, etc., it is difficult to distinguish between the echoes of buoys and ships. Local knowledge and the reduction of gain can offer great assistance. The chart must be thoroughly studied for radar echoes, especially the echoes of buoys. This makes it easier to pick out echoes of ships and other moving objects. In order to make small objects better visible on the radar, objects known to give poor radar echoes can be equipped with radar reflectors. There are several types of radar reflectors on the market. all have the same function: directing the radar pulse back to the antenna in order to increase radar detection range for a particular target. A radar reflector placed on a circular object, a buoy, beacon, etc., can increase the detection range considerably. In order to obtain positive identification of radar targets, beacons have been established. Raycon is a radar transponder, which emits a characteristic signal when triggered off by a ship radar transmission. A Raycon signal appears on the PPI as a radial line originating from a point just beyond the position of the radar beacon. The line is often divided into dots and dashes, forming a Morse code signal. Raycon provides both bearing and range information of the target. Raycons used by the maritime industry are only triggered by X-band radars. With a gyro-stabilized radar presentation in operation, the parallel index lines provide a useful means of planning a passage at a required distance off a point of land or another selected object. The use of parallel index lines is straightforward, as the navigator sets the cursor's bearing line to the course required to make good. Then he manoeuvres the ship so that the target's echo moves along the parallel index line, which passes the required distance off the centre of the display. This example shows the parallel index lines set to make good, a northeasterly course to pass an island to port. The difference between the direction of the heading marker and the parallel index lines is the allowance, which has to be made for the northwesterly current. Remember, radar navigation has three important motion components. It is particularly important to remember that we are always talking of courses and speeds during a terminated period of observation. The target's relative course and speed is the target's motion in relation to own ship during the period of observation. This corresponds to the echo's movements across the PPI on the relative motion display. The target's true course and speed is the target's true motion during the period of observation. This corresponds to the echo movements across the PPI on a true motion display. The own ship's course and speed are your ship's true motion during the period of observation. The learning objective of this section is to draw the student's attention to the fact that it is clearly stated in the COLREG that the COLREG rules shall be followed by all ships. There are no exceptions for ships equipped with radar. Following the COLREG at all times is good seamanship. The same rules for preventing collisions apply to all ships, and the use of radar is compulsory for assessment of close-quarter situations. Even a good working radar system, operated by a certified operator, does not give any special rights to that ship. Make it a habit always to follow the COLREG rules, as this will save you a lot of trouble and it makes your job easier. Intelligent use of radar is to use the system as an early warning device, and plan and execute all avoiding manoeuvres as early as possible. This is actually the only safe use of radar whenever it's used primarily for traffic monitoring. In order to obtain a radar observer certificate, simulator training is compulsory. The required simulator training is offered by several training institutions around the world, including Seagull AS in Norway. Irrespective of the place chosen for simulator training, we strongly recommend thoroughly refreshing the COLREG rules, as this always plays an important part in the radar simulator training and is a must to master in order to successfully complete the course and obtain the radar observer certificate. Here is an overview of the COLREG rules, which is relevant in connection with radar traffic surveillance during reduced visibility. COLREG Rule 2 states the responsibility of the owner, master and crew. COLREG Rule 4 states steering and sailing rules to be used in any condition of visibility. COLREG Rule 5 specifically deals with the importance of maintaining a proper lookout by all available means. COLREG Rule 6 introduces a new concept, namely safe speed at all times. COLREG Rule 7 states that all available means should be used to determine if risk of collision exists. COLREG Rule 8 states that all actions to avoid collision should be positive and made in ample time. COLREG Rule 10 specifically deals with sailing and traffic separation schemes. COLREG Rule 35 specifies sound signals to be given during conditions of bad visibility. You will now be asked some questions.